Inverse trig functions, 13.4. This is kind of like, you've seen it before, believe it or not. You've done inverse trig functions. When you had to find the angle. If you think back to right triangle trig, and you needed to find theta, knowing that this was a 5 and that's a 9, what trig function would you use to find theta? Cosine. I would use cosine. I know that the cosine of theta would be 5 over 9, so the inverse cosine, that -1 button, remember that?
Yeah.
And what this was asking, what angle has the cosine value of 5/9, excuse me. That's what that meant, using inverse trig functions. But what we're going to do is use it in terms of placement on the unit circle, as well as some very simple one-step trig equations that bounce into different quadrants. Being able to do that and get good at the inverse stuff is going to allow us to solve equations probably starting on Friday. Okay? And I'll show you where this all leads to. But in order to do any of this, we have to set some specific parameters for how you find theta in relation with cosine, sine, and tangent. So there's 3 rules. In order to evaluate inverse trig function, you've got 3 I just want to do the cosine inverse, sine inverse, and tangent numbers. There are 3 rules for how these work. When you're finding a cosine, an inverse trig function for cosine, you're only looking between 2 specific quadrants. You're looking between 0 and pi. Otherwise known as 0 and 180 degrees. What's your ordered pair at 0? 1, 0. Here it's 0, 1. And here it's at -1 and 0. So if I'm looking at that, I know that cosine is never greater than 1. Cosine is never smaller than -1. It's always going to be the cosine of theta, I should have a theta here, is always less than 1, but it's always greater than -1 because of the unit circle. Right? It goes between 0, the angles themselves go from 0 to pi, and that's how you bounce them through. Now think about it. We have all of our positive values here in the first quadrant, all of our negative values in the second quadrant. When you look at sine values, it's a little bit different. Yeah, first and fourth. I might have shown you that already. Sine values go between first quadrant to fourth quadrant, but what they do, they don't call that 3 pi over 2. Since it's a continuous from positive to negative, they call it from pi over 2 to negative pi over 2. Okay? So all of your angle values are going to be somewhere between 45 and -45. So they go from 0, 1, 0, -1, and obviously they become 1, 0, yeah, 0. Again, sine can never be greater than 1. It's never going to be less than -1. And you might have seen that before. Remember how you guys would get that domain error on the calculator every once in a while? Because you accidentally hit the sine of some value as opposed to the inverse sine? Or you hit the inverse sign instead of the sign. That's why that happens. They don't go any larger than 1 or smaller than -1. Okay. So far, so good?
Gouda? The cheese?
Yeah,
Yes.
it's a type of cheese.
I get it. That was nacho Gouda. And then tangent mirrors sine, but it has an open circle on pi over 2, negative pi over 2. Because what's the ordered pair on that quadrant? Tangent's y over x, isn't it?
Yeah.
Can you divide by 0? That's why it's an open dot.
Ding dong.
Thank you. So when we're working with these things, we're going to be using reference angles. We're going to bounce stuff back and forth. Again, you'll see the big importance of using reference angles because that's kind of all we do in this whole chapter is work with reference angles, in case you haven't figured that out yet. It's not stupid, it's important. Hi, speaking of important.
Okay, your sign,
Yeah,
like, you know how you wrote cosine is like greater than, is there anything?
it's near the same thing. Sine, same thing with sine.
Oh, okay, so it's just the same thing.
Yeah. Tangent. Tangent's different. Tangent's different. You can get it. Tangents can be larger than one.
Wow.
Okay? And because of the relationship with the fractions of the sines and cosines, because of the ordered pairs. Because when you start placing things in space, as soon as you place any spot in space and you draw your ordered pair out here, the R value doesn't matter. Okay? But if this side here is 7 and this is 2, it's y over x, isn't it? Yeah. So tangent of theta can be larger than 1. Tangent of theta can be less than 1. Or less than negative 1 as well. It doesn't, and that's the point. As you're fluctuating back and forth between tangent values, as we go to graph this stuff next week sometime, tangent at pi over 2 and negative pi over 2 would have an asymptote because of the open circle. Where is tangent equal to 0? 0. Where is tangent equal to 1? Yes, sir.
Why is the open circle given asymptote?
Can you divide by 0?
No.
That's why.
Well, why is that given an asymptote?
Because when you go to plot
Because
these,
it can't
when you
go
got,
on.
at the unit circle when you're here, your ordered pair is 0, oh, excuse me. It's 1, 0. No, I had it right, sorry. Duh. So the tangent at pi over 2 would be 1 over 0, which is undefined. So at pi over 2, it's an undefined, so you have a vertical asymptote.
So it can't be that, so it goes as close to this.
Correct. Think about your unit circle. In order for tangent to be equal to 1, that means that your opposite and your adjacent are the same value. What triangle has opposites and adjacents that are the same value? 45. So that means at 45 degrees, pi over 4, tangent is 1. At negative 45 degrees, tangent is negative 1. So tangent, as we were saying a second ago, can be greater than 1 or less than negative 1. Tangent looks like this as it wraps, because it's got those asymptotes right there. They're going to get infinitely closer as they go through. Whereas sine and cosine oscillate. There's no barrier upon their graph. Okay. That's what we get into. That's why you have that open circle on a tangent. This is more stuff for next week, but just how we're going to set these things through. So what we're going to ask you guys is this. What angle has a sine of root 3 over 2? So what you have to figure out then, without the use of the calculator, you had this, is what you're going to say. You have to figure out in your mind which triangle works with root 3's and 2's. 30, 60, 90. So you write it out. Which one of those angles has a sine of root 3 over 2? 60. So my answer is 60 degrees. And I also put my answers in both degrees and radians. What's 60 in radians?
Oh, yeah.
pi over 3. That's what this looks like.
Wait,
Yes, sir.
how did you determine that it was gonna have to be a 3069?
There's only 2 triangles we can work with, as well as quadrantis. When I see a root 3, which triangle has a root 3 in it?
What a 3069.
That's all it is.
Okay, thank you.
That's all it is.
Pi over
60 degrees radians.
3. So it's 60 or pi over 3.
Yep.
It's not 60 pi over 3.
No, it's degrees and radians. You're going to give your answers both.
Okay, all right.
Okay.
So what if it was like sine -1
Can you get that? It's so funny that you ask. What angle has a cosine of 2?
45.
No. Because it doesn't work.
But 30, 60, 90,
Correct. So if you think about it, 30, 60, 90. Which one of those has an adjacent over a hypotenuse that gives you 2?
inverse cosine.
Which angle
Oh,
has
it's 9.
the cosine of 2? None.
It's 9.
No. No. You cannot get you can't find an angle that has a cosine greater than 1.
I bet I can.
Cosine is never larger than 1. It is never smaller than -1. So the answer is no. Yes, sir.
Why is it the inverse cosine if you're solving for the cosine?
What this is asking, which angle has? What angle has the cosine of 2? What angle has the tangent of -1? That's what that means. When we did law of sine, we had to find like sine of A equaled all that decimal. What angle has a sine equal to that decimal? You'd inverse sine to find the angle. Okay, that's what this says. Yes, sir.
So like a cosecant though.
We don't worry about reciprocal properties yet,
Okay.
because if it's a reciprocal property, you just flip the fraction.
Okay.
I can do what angle has a cosecant of 2.
Yeah, that would be.
I can do that.
Okay, that was.
Okay. What angle has a tangent
We're not gonna worry about
of -1?
No.
No.
Yeah.
It's on an asymptote. What?
45, 45, 90 has tangents of 1, doesn't it?
Yeah.
Well, where's tangent negative?
Oh, tendency.
At negative 45 degrees. Okay? It's down below it. At negative, so what angle has a tangent of -1? What? Negative 45 degrees or negative pi over 4. We are not using counterclockwise angle theta. Okay, we're not going around like we would and saying it's 315 degrees. It's negative 45. Tangents parameters between positive pi over 2, negative pi over 2. That's the answers that you give them, okay, within those 2 values. Same thing with sine and cosine. You don't have to spin them all around. Let's do some more. Inverse tangent root 3. What angle has tangent of root 3? Well, which triangle has root 3s? 30, 60, 90. So, which one of those has a tangent of root 3? 60. So my answer is 60 degrees or
Are all cosine and sine are in between -1 and 1 and tangent?
there's no Okay. Root 2 over 2. Which angle is that? It's 45, 45, 90.
Man, this is easy.
Cosine 45 is 1 over root 2.
How about
Simplified out, root 2 over 2. So which angle is it? The 45 or the 45?
It's 90. Thank you. It's not.
you can't do these trig functions from 90, right?
Correct. You can do trig functions at 90, but then you're talking about your you're talking about your quadrantals. I can do it for sine and cosine, but I can't do it for tangent. What angle has a sine of 0?
0.
90. What angle has a cosine of negative 1?
90.
180. Pi. Yes, sir.
How do you determine the quadrant it's in, if it's like a negative cosine or something? If it's like negative cosine.
Yeah, inverse cosine.
Negatives. Like something, I don't know.
Oh, we've got more. Oop. Like that. Let's do the sine one real fast, and then we'll go to the other one. What angle has a sine of 1/2? I know it's a 30, 60, 90. Very good.
No.
Oh, geez, I wonder what it was.
Gee, which one is it?
Maybe we'll make a late one.
The 30 degrees. What's 30 degrees in radians?
Do we have to answer in both degrees?
Yes. Yep. Always give both. Now here's, Mr. Pope, what you're asking. What angle has a cosine of negative 1/2? Well, cosine we know is negative in the second quadrant, so it's going to be an obtuse angle. Okay. So what triangle has the 1/2s in it? 30, 60. Very good. So here's our 30, 60. So it's 1, root 3, and 2. Which one of those is 1/2 for cosine?
60.
The 60. Good. Now what you're finding here is the reference angle in the first quadrant. I heard somebody already say it. But I'm looking for it to be negative, which means it's over here, up 60, so it is at 120. So it's 120 degrees. Now think of this in terms of pi. 60 degrees was pi over 3, correct? It's pi over 3 away from a full pi, so it is 2 degrees. How are you? What's that? Oh, thank you. Appreciate it. See how that works out then?
I'm still a little confused how you know which quadrant it's in.
You're using your reference angle, and if it's negative, you just have to remember that cosine goes negative the second. Whereas when we had the negative sine values, it just, because of the way the parameters are, since we have the rules for sine, cosine, and tangent, I'll just put it down here. Since we have the rules for sine, cosine, and tangent, you're looking between the two quadrants there. That's where it's always going to be. The sine values.
And then the negative is going to tell you where it's negative.
Yeah. So this is going to be between 0 and pi. This is between pi over 2 and negative pi over 2. And then tangent was with it with the open circle. Yes, sir?
For the test, are we gonna, or should we memorize the unit circle?
You don't need to memorize it. The only thing you have to know about the unit circle is which angle's first.
Okay.
If you know that, everything falls into place. I mean, quite honestly, that's all you need to know. Because everything else is buildable. Exactly. It's like building Legos.
Or bears?
Just sine and cosine are between -1 and 1. Tangent, as you can see, doesn't have a parameter. Okay. We did this already earlier. Blah blah blah. Let's go into an equation. I know you're going to be happy to hear this. You need a calculator. Okay? You need to have your calculator for this.
I knew you'd come through.
I know. This is the one part of this chapter again that a calculator is kind of needed to do. And you've actually done this before. What this equation is asking sine of theta equals negative 1/4, and they want you to move it to a different quadrant. Okay, so the sine of theta equals negative 1/4. How do you find theta? What button do you press? Negative sign. So theta is going to equal the inverse sine. Make sure you are in degree mode of negative 1/4. Be honest with you, it's quicker to type negative 0.25. Watch what happens. Inverse sine negative 0.25. I get a negative angle. Because where is sine trying to find it? It's trying to find it in that fourth quadrant because it's negative. So right now, I have an angle of 14.48. Always go 2 decimal places. I have an angle. It's 4.8. I have an angle in the fourth quadrant of negative 14.48. But they're asking me to find where is its match in the third quadrant, which means you have to find its reference angle. What's the reference angle to negative 14.48?
14.48.
Very good. Your reference angle is 14.48, which means if I want to be in the third quadrant, I move down 14.48. What's 14.48 more than 180?
194.48. They said first.
And here's what's great. You can double check your work because if I type in my calculator now, sine 194.48, da, 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 negative 0.2500004. Yes, ma'am.
Why does it go into the center?
It's just asking you to figure it out. It'll ask you another quadrant to move it to. It'll always have something in here. For example, here it's asking for what angle has a negative sign of what angle has a sign that's negative 1/4. Sine's only negative in 2 quadrants, fourth and third. If the reference angle is going to bounce into the fourth, bless you, start in the fourth, the only other place it could happen would be third. Same thing with cosine. If they give you a cosine negative, the only way you're going to get a cosine negative would be also the third quadrant. Tangents, they can switch between, where your signs are the same, your positives are the same, or the negatives are the same, things like that. But that little parameter will always be given to you. Is that what you're about to ask too? Yeah. Everybody always asks that. How will I know which quadrant? Well, it's really just what other quadrant is it negative, or which other quadrant is it positive. Yeah.
Wait, you said cosine will be negative in 2.
Yeah. Yeah.
It also says like that you have to reflect the angle to within the third quadrant in the problem.
That's what we did.
Yeah.
I just used the reference angle. That's all.
Yes.
That's all.
Okay.
I don't-
That's the only other place that it's negative, and it's telling you to go to the
Yeah,
quadrant.
it's just, that's the whole idea when we built the unit circle, knowing that these y values are the same because the angle spots, that's how it works. And that's the whole point of all trig, knowing your x, y's, and r's. That's it.
Is there a lot of trig and pre-calc?
Yes. Oh, God, yes.
Oh,
Wait, so with your answer, does the other one be 100?
oh man.
Yeah. Try these two. I got the sine of theta equals negative 0.35, which means it's going to start in the fourth, you have to bounce it to the third. And then it has tangent of theta equals 2.4. And remember, tangent is positive, it's going to start you in the first quadrant, and it's going to want you to bounce that to the third quadrant because the tangent is also positive in the third. So we do the same thing. We press buttons. We get a reference angle. We bounce things around. Negative 20.49. Everybody get that?
Yes.
So we are down negative 20.49. Which means my reference angle is 20.49, so I move that to the third quadrant, and my angle is 200.49.
Wow, that's,
With these ones, we don't need to convert to radians?
No, with these things it'd be awful. I mean, you can.
let's not.
It's 200.49 pi over 180. Go to the next problem. All right, you guys do the tangent one. Well, they're really, I don't know if there's one any more difficult than another. Sixty-seven 38 goes to what quadrant? Well, it starts where? If I have to go to the third quadrant, what do I do?
Add 180.
That's 180. And what'd you get?
247.38.
You can always check it. Tangent, 247.48, or excuse me, 38.
Pretty close to 2.
What's wrong with Shipkey?
Oh, we're trying to get 2.4.
I've got you under my skin. I've got you deep in the heart. Yeah, I'm really not good with the Frank. What else we got?
Frank Sinatra. There's a Frank Sinatra. Mr. Murphy, there's a Frank Sinatra.
Oops. Look. Cosine of theta is 0.43, and it wants to go to the fourth quadrant.
Mr. Murphy, is this one of those things that it's like preparing us for something else, or is this one of the things that we prepared for?
Yes. This is preparing you for something else, and I'll show you what this is preparing you for. Okay? Let's just do this one cosine problem, and I'm going to show you. It's funny because someone asked that exact same thing third hour at about the same point. They're like, "What is this prepping me for? Because it seems a little easy right now. When does the other shoe drop?"
I
So.
just feel like you've been building up and building up. I'm just waiting for it all to fall down.
What angle did you get in the first quadrant for that? 64.53. Now be careful. When you're using your reference angle to the fourth quadrant, what are you doing? No. Subtracting from 360. Remember, your reference angles are all bounced off the x-axis. Okay? That's usually where people mess up. They will accidentally go off 270 and not subtract from 360. So you have to subtract 360 minus the 64. Okay? Does that make sense?
It makes sense. What is it?
JC?
Yes.
So, where is this getting us to? Well, it's going to get us to be able, can I go to a clean one here?
Nope. No, yeah.
It's getting us to this. You're going to solve for x. And I'm going to solve for x. I'm going to solve for x, and I'm going to find all possible values of x within one revolution of the circle. I'm going to find all possible values of x that make this a true statement. Now, if this was just 2x minus 1 equals 0, what would you do to solve for x? Add 1, divide by 2. Okay, what do you think you do now?
Add 1 divided by 2.
So you get 2 times the cosine of x equals 1. divided by 2. Cosine of x equals 1/2. Which means x will be what angle has the cosine of 1/2. It's got to be which triangle? It says 30, 60, 90. 1 root 3 and 2. Which one of those angles gives me 1/2? 60.
So would that be a 900?
Oh, absolutely. So this happens at 60 degrees, pi over 3. Where else is cosine positive within one revolution?
In the
First and
third.
fourth quadrant. Cosine's positive in 2 quadrants, first and fourth. This angle gives me the reference angle within the first quadrant. I know that in the first quadrant, reference angle, 60 degrees. If I go down 60 degrees, what's my terminal side? 300. Otherwise known as, it's a pi over 3 less than 2 pi.
5 pi.
Very good.
You said terminal side. Can you like explain it?
Terminal side, remember, it spins.
Oh, okay.
So what happens here is that you're going to be able to use the inverse properties, what angle has, and figure out all the possible values of theta or x, whatever it is, within one revolution of the circle. Because there's multiple times cosine's positive 1/2. Okay? We'll also talk about it in terms of what's called a general solution, which means there's no restriction on the revolution around the circle. But it all stems from being able to get this. If we can do this, which is what you're working on today, solving it into the circle is easy. Okay? It's relatively simple because you're just using reference angles. And where are the signs SIGN? The same. Okay? That's how it works out. See where I'm getting to? Let's do some problems. I forget what page it is. Nobody has it. Martine has a book. She's well prepared.
That book is on the internet.
I'd like you guys to do, this is page 795. Let's do 18 through 28 and 44 to 55. Okay? They are the ones, what angle has, what angle has, what angle has. It's real fast stuff you should be able to go through. For example, what angle has a sine of root 2 over 2? 45. So what is 45 in terms of radians then? And then go to the next problem. Okay?
Mr. Murphy,
Yes, absolutely.
are we gonna get like, does this like start to like click at a certain point and then like we just instantly recognize different?
You should be clicking by now. Should be clicking.
All right.
Should be clicking. Remember, all you're looking at here, guys, as we're going through, is that it's always bounced out of one of the special triangles. Bounce out of a special triangle. It bounces off a quadrantal. The ones you have to use your calculator for, you're just pressing buttons and then using that as a reference angle. Usually what people screw up is going into the fourth quadrant because you have to subtract from 360. Okay? That's usually where you mess up.